Okay, so we see AI doing these absolutely incredible things every single day, right? It's rating code, it's creating mind-blowing art, you name it. But what if I told you that underneath all of that jaw-dropping power, there's a fundamental, almost silly flaw that stops it from tackling truly massive projects?
Think about it like this. Could an AI follow a to-do list with, say, 1,000,000 steps and do it perfectly without a single mistake? It seems like a pretty basic question, but the answer reveals a huge crack in the very foundation of modern AI.
And this all comes down to expectation versus reality. We kind of expect an AI to build a digital skyscraper just flawlessly, but the reality is, even the absolute best models have a small error rate. Let's say it's just 1%. Sounds amazing, right? 99% accurate? But here's the catch. Over a long project, that tiny, tiny error guarantees failure. One wrong move, one misplaced brick, and the whole thing just comes crashing down.
And look, this isn't just me guessing. A research paper I've been digging into puts it so bluntly. It says with a 1% error rate, your system is expected to fail after only about 100 steps. So how could an AI ever hope to complete a 1,000,000-step task? It seems impossible. To solve this, researchers needed a test, and not just any test. They needed the ultimate AI gauntlet, a problem so incredibly long and demanding that it would just break any normal AI that tried it. So the challenge they chose was the Towers of Hanoi. You've probably seen it. It's that classic puzzle where you move discs between pegs, but you can never, ever put a larger disc on top of a smaller one. The fascinating part, the reason they chose this, is how it scales. With just 20 discs, the solution takes over 1,000,000 steps. And one single mistake, anywhere along the way, and it's game over. And just look what happened when they put the AIs to the test. Even the heavy hitters, models like GPT-4, they all failed after just a few hundred steps. They couldn't handle it. But the system from this paper, a system called Maker, it completed all 1,048,575 steps perfectly, not a single error. So the million-dollar question is, how on earth did they do it? The answer is completely counterintuitive. They didn't build a bigger, smarter AI. Instead, they did the opposite. They decided to smash intelligence into tiny little pieces. This is the big idea that just flips everything we think we know on its head. What if the path to super reliable AI isn't building a single genius model that tries to do everything at once? What if instead it's an army of tiny, simple AIs where each one is laser-focused on a single microscopic task? The researchers have a name for this, of course, massively decomposed agentic processes, or MDAPs. But the core idea is really simple. Instead of giving one AI a 1,000,000-step problem, you break that problem into 1,000,000 tiny individual steps. Then you give each one of those tiny steps to its own separate little micro-agent. But, just breaking the problem down isn't quite enough. You still have that pesky little error rate to deal with. The real magic, the secret sauce, comes from how these little microagents work together. It turns out having them vote is way more effective than just relying on a single genius. Here's how the system works in 3 pretty simple stages. First, you decompose the task. You break it down into the smallest possible pieces. Second, for each one of those tiny steps, you have several AI agents all propose a solution, and then they vote on the best one. And third, something they call red flagging. If any AI gives a weird, badly formatted, or just nonsensical answer, you just throw it out. It's a surprisingly tough and robust system. Think back to that skyscraper for a second. Now, imagine that for every single brick that needs to be laid, you have a small team of builders. They all look at the problem, they vote on the absolute best way to lay that one brick, and you have a supervisor who instantly rejects any crazy ideas. What do you get? A perfectly laid brick. Now do that 1,000,000 times over, and you get a perfect skyscraper. So does this wild idea actually work when the stakes are this high? I mean, this is 1,000,000 steps. Let's look at the final, stunning results of the experiment. First, just a reminder of the sheer scale of this thing. Over 1,000,000 consecutive steps, every single one has to be perfect because it depends entirely on the last one. That's what it takes to solve this puzzle. And the number of errors this system made across those 1,000,000+ steps? 0. A big, fat 0. Absolute perfection on a task that completely broke every other AI that tried it. And we can actually see it in action here. This is a visualization from the paper showing the system partway through its perfect run. Each one of those dots is a step, a tiny agent doing its one job perfectly, forming this massive, unbreakable chain of reliable actions. It's incredible.
Look, this is an amazing achievement, for sure, but it's way more than just a cool solution to a puzzle. This suggests a completely new path forward for how we build and how we should think about AI. So why does this change everything? Well, 3 huge reasons. First, reliability. This is basically a blueprint for how we could build AI for safety-critical fields like self-driving cars or medicine. Second, it's cheaper and more efficient. And this is the part that blew my mind. The system actually worked best, not with the giant, expensive models, but with smaller, cheaper ones. Why? Because a massive model might overthink a simple step, while a small, simple model just does its simple job. The voting system then cancels out any random errors. And finally, safety. Instead of building one giant, unpredictable black box AI, you have millions of tiny, transparent, controllable parts. It's a potential path to building powerful AI that is inherently safer.
The paper sums up this whole philosophy perfectly with this powerful line. It's not about making AI bigger, it's about making it smarter by breaking it down into a million reliable pieces.
And that leaves us with a final, fascinating question to chew on. Maybe we've been looking at the future of AI all wrong. Maybe it's not about building a single godlike superintelligence, but a collaborative swarm of a billion micro-intelligences, all working together in perfect, reliable harmony. What do you think?